When wiring Hotlegs in a multiple switch box, the preferred method is to use multiple pigtails rather than a single, long pigtail. This approach offers several advantages in terms of safety, reliability, and performance. Using multiple pigtails helps reduce the risk of overloading the neutral wire. When a single long pigtail is used, the entire current from all the switches connected to the box flows through that single wire. This concentrated current flow can lead to increased resistance within the wire. Increased resistance in turn causes a voltage drop, meaning that the voltage available at the switches may be lower than the intended voltage. This voltage drop can negatively affect the performance of the switches, causing them to operate sluggishly or even fail prematurely. Furthermore, a single pigtail represents a single point of failure. If that pigtail becomes damaged or disconnected, it can disrupt the power supply to all the switches connected to the box, causing them all to stop working simultaneously. By using multiple pigtails, the current is divided among multiple wires. This distribution of current reduces the electrical load on each individual wire, thereby minimizing resistance and voltage drop. Each switch effectively has its own dedicated connection back to the power source, reducing the likelihood of one switch affecting the performance of another. Multiple pigtails provide a level of redundancy. If one of the pigtails fails or becomes disconnected, the other pigtails will continue to provide power to their respective switches. This ensures that the entire system does not fail due to a single point of failure, enhancing the overall reliability of the electrical system. This redundancy is a key safety feature, as it reduces the likelihood of a sudden loss of power to critical circuits. The National Electrical Code, or NEC, provides guidelines for safe wiring practices. While the NEC does not explicitly mandate the use of multiple pigtails in all situations, it emphasizes the importance of proper wire sizing and connection methods to prevent overheating and voltage drop. Using multiple pigtails can be seen as a way to comply with the spirit of the NEC by ensuring that conductors are not overloaded and that voltage drop is minimized. When installing multiple pigtails, it is essential to follow proper wiring techniques. Firstly, use wire connectors that are appropriate for the size and type of wires being connected. Wire connectors, such as Y-nuts or push-in connectors, should be listed by a recognized testing laboratory such as Underwriters Laboratories or UL to ensure that they meet safety standards. Secondly, ensure that all connections are tight and secure. Loose connections can create resistance, leading to heat buildup and potential fire hazards. Thirdly, use the correct wire gauge for the circuit. The wire gauge should be appropriate for the amount of current that the circuit is expected to carry. The NEC provides tables that specify the allowable ampacities, or current carrying capacities, of different wire gauges. For example, NEC Table 310.15b16 provides ampacity ratings for conductors based on their insulation type and ambient temperature. It's important to consult this table and other relevant sections of the NEC to determine the appropriate wire gauge for the application. When making pigtail connections, strip the insulation from the wires carefully, ensuring that the bare wire is not nicked or damaged. Damaged wires can be more susceptible to corrosion and breakage, which can compromise the integrity of the connection. Twist the stripped ends of the wires together tightly before applying the wire connector. This ensures a good mechanical connection and reduces the risk of the wires coming loose over time. Once the wire connector is installed, give the wires a gentle tug to verify that the connection is secure. If the wires pull out of the connection is not properly made and needs to be redone. When working with electrical wiring, always de-energize the circuit before starting any work. This can be done by turning off the circuit breaker or removing the fuse that applies power to the circuit. Use a voltage tester to verify that the circuit is indeed energized before touching any wires. This simple step can prevent electric shock and save lives. Wear appropriate personal protective equipment or PPE, such as safety glasses and insulated gloves. Safety glasses protect the eyes from flying debris, while insulated gloves protect the hands from electric shock. It's also a good idea to wear clothing that covers the arms and legs to provide additional protection. Work in a well-lit area. Proper lighting makes it easier to see what you are doing and reduces the risk of making mistakes. If necessary, Use a portable work light to illuminate the area where you are working. If you are not comfortable working with electrical wiring, hire a qualified electrician. The electricians have the training and experience necessary to perform electrical work safely and correctly. Trying to do electrical work without the proper knowledge and skills can be dangerous and can lead to serious injury or property damage. The choice between using a single long pigtail and multiple pigtails for Hotlegs in a multiple switch box is not just a matter of preference, it is a matter of safety and reliability. Multiple pigtails offer several advantages, including reduced risk of overloading, minimized voltage drop, and increased system redundancy. By following proper wiring techniques and adhering to the NEC guidelines, you can ensure that your electrical system is safe and performs reliably for years to come. When considering the electrical load on a circuit, it's important to calculate the total current that will be drawn by all the devices connected to the circuit. This calculation should take into account the wattage of each device and the voltage of the circuit. For example, if you have a 120-volt circuit with 3 100 watts light bulbs, the total current drawn by the light bulbs would be 2.5 amps. This is calculated by dividing the total wattage, which is 300 watts, by the voltage, which is 120 volts. Once you have calculated the total current, you can use this information to select the appropriate wire gauge and circuit breaker size. The wire gauge should be large enough to handle the total current without overheating, and the circuit breaker should be sized to protect the circuit from overloads. It's also important to consider the dirting factors that may apply to the wire ampacity. Dirting factors are adjustments to the allowable ampacity of a wire that are required under certain conditions, such as when the wire is installed in a conduit with other wires or when the ambient temperature is high. The NEC provides tables that specify the dirting factors that apply in different situations. In addition to using multiple pigtails, there are other ways to improve the reliability and safety of electrical connections. One way is to use antioxidant compound on all aluminum wire connections. Aluminum wire is more susceptible to corrosion than copper wire, and corrosion can increase the resistance of the connection, leading to heat buildup and potential fire hazard. Antioxidant compound helps to prevent corrosion and maintain a good electrical connection. Another way to improve the reliability of electrical connections is to use torque screwdrivers or torque wrenches to tighten the connections to the proper torque. Over-tightening or under-tightening connections can both lead to problems. Over-tightening can damage the wires or connectors, while under-tightening can result in loose connections. Torque screwdrivers and torque wrenches ensure that connections are tightened to the proper torque, which helps to prevent these problems. Regular inspection and maintenance of electrical systems are also essential for ensuring safety and reliability. Electrical connections should be inspected periodically for signs of corrosion, damage, or looseness. Any problems that are found should be corrected promptly. Circuit breakers should be tested periodically to ensure that they are functioning properly. If a circuit breaker trips frequently, it may be a sign that there is a problem with the circuit that needs to be investigated. In addition to the technical aspects of wiring Hotlegs in a multiple switch box, it's also important to consider the human factors. Electrical work can be dangerous, and it's important to be aware of the risks involved and to take precautions to minimize those risks. Never work on electrical wiring when you're tired or distracted. It's important to be alert and focused when working with electricity. Avoid working in damp or wet conditions. Water is a good conductor of electricity, and working in wet conditions increases the risk of electric shock. Use tools that are in good condition. Damaged or worn tools can be dangerous to use. Keep your work area clean and organized. A cluttered work area can increase the risk of accidents. When working with electrical wiring, it's always better to be safe than sorry. If you are not sure about something, ask a qualified electrician for help. The NEC is updated every 3 years to reflect changes in technology and best practices. It's important to stay up to date on the latest version of the NEC to ensure that your electrical work complies with current standards. Many jurisdictions require electrical work to be inspected by a qualified electrical inspector. Electrical inspections help to ensure that electrical work is done safely and correctly. If you are planning to do any electrical work, check with your local building department to see if an inspection is required. Proper grounding is also essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electric shock. All electrical equipment should be properly grounded, and the grounding system should be tested periodically to ensure that it is functioning properly. Surge protection is another important aspect of electrical safety. Surges are sudden increases in voltage that can damage electrical equipment. Surge protectors help to protect electrical equipment from damage caused by surges. Surge protectors should be installed at the service entrance and at individual electrical outlets to provide comprehensive surge protection. Arc fault circuit interrupters or SIs are another important safety device. SIs are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. SIs trip the circuit breaker when an arc fault is detected, which helps to prevent fires. SIs are required by the NEC in many locations, such as bedrooms and living rooms. Ground fault circuit interrupters or GFCIs are another important safety device. GFCIs are designed to detect ground faults, which are electrical conditions that can cause electric shock. GFCIs strip the circuit breaker when a ground fault is detected, which helps to prevent electric shock. GFCIs are required by the NEC in many locations, such as bathrooms and kitchens. In addition to the safety devices mentioned above, there are other safety measures that can be taken to reduce the risk of electrical hazards. One measure is to use tamper-resistant receptacles. Tamper-resistant receptacles have shutters that prevent children from inserting objects into the receptacle slots. Another measure is to use cord protectors. Cord protectors help to protect cords from damage and prevent tripping hazards. It's also important to teach children about electrical safety. Children should be taught not to play with electrical outlets or cords and to stay away from electrical equipment when it is in use. By taking these safety measures, you can help to protect yourself and your family from electrical hazards. Choosing the right type of wire for an application is crucial for safety and performance. Different types of wire are designed for different purposes and have different properties. For example, THHM wire is a common type of wire that is used for general purpose wiring. THHM wire has a thermoplastic insulation that is resistant to heat and moisture. UF wire is another type of wire that is used for underground wiring. UF wire has a waterproof insulation that protects the wire from moisture. The size of the wire also matters. The size of the wire determines how much current the wire can safely carry. The NEC specifies the allowable ampacities for different wire sizes. Using a wire that is too small for the application can cause the wire to overheat and potentially start a fire. Proper labeling of electrical circuits is essential for safety and troubleshooting. All circuit breakers should be labeled to indicate which circuits they control. This makes it easier to turn off the correct circuit breaker when working on electrical wiring. It also helps to prevent accidental shutdowns of critical equipment. In addition to labeling circuit breakers, it's also a good idea to label electrical outlets and switches. This can help to identify which outlets and switches are controlled by which circuit breakers. When troubleshooting electrical problems, it's important to have a systematic approach. Start by checking the circuit breaker to see if it has tripped. If the circuit breaker has tripped, reset it and see if it trips again. If the circuit breaker trips repeatedly, there is likely a problem with the circuit that needs to be investigated. Use a multimeter to test for voltage and continuity. A multimeter is a versatile tool that can be used to measure voltage, current, and resistance. It can also be used to test for continuity, which means checking to see if there is a complete electrical path between 2 points. Inspect the wiring for any signs of damage. Look for frayed wires, loose connections, and signs of overheating. If you find any damage, repair it immediately. If you are not comfortable troubleshooting electrical problems yourself, hire a qualified electrician. Electricians have the training and experience necessary to diagnose and repair electrical problems safely and correctly. Remember, electrical safety is not just a set of rules and regulations. It is a mindset. It is about being aware of the risks involved in working with electricity and taking precautions to minimize those risks. It is about using common sense and following safe work practices. By making electrical safety a priority, you can help to protect yourself and your family from electrical hazards.